entirely on the emergence of the 1D universe, the space-time band model, and all the related phenomena we've discussed. The universe can be imagined as beginning from a single unanchored 1D line, an extremely flexible filament without any preferred direction. This initial line drifted freely through a primordial void, and small perturbations accumulated over time, creating initial folds and overlaps. These perturbations naturally produced stress and torsion as the line stretched, laying the groundwork for layered spatial structures. As the 1D line continued to drift and expand, it began stacking into two-dimensional bands. This transition was driven by symmetry breaking. The line could no longer remain a simple one-dimensional filament without generating tension gradients. Folding, buckling, and overlapping produced thickness, and the bands formed the first scaffolding of spacetime, carrying both mass and energy. The early bands were loose and flexible, able to slip and twist freely. This flexibility allowed local decoupling to happen naturally, letting regions of the fabric separate slightly from their neighbors. In these zones, energy and matter could accumulate, forming primitive gravitational wells. Gravity emerged not as a force, but as the mechanical response of unevenly stacked bands to tension and curvature. Dense zones in the early bands attracted matter along paths of least resistance through folds and overlaps. Protostars and matter concentrations formed where torsion and stress were naturally high. The fabric's elasticity enabled expansion and motion without catastrophic tearing, guiding matter and energy into the structures that would eventually become planets, stars, and galaxies. Introducing rotation in massive bodies caused local twisting of the bands. Rotation didn't drag the entire fabric, but produced isolated pockets of concentrated curvature. These pockets formed self-contained knots in the space-time bands, allowing massive objects to exist and spin without entangling the surrounding cosmic network. Local twisting and decoupling concentrated enormous energy and stress in small patches. These isolated zones could become proto-universes or microcosms, effectively self-contained systems where matter and energy organized independently of the surrounding space-time. The energy stored in these torsion zones manifested as extreme heat. This heat wasn't a side effect. It was a direct result of stored geometric tension in the twisted, compressed bands. A decoupled patch could act as a natural high-energy reservoir, continuously releasing thermal flux as the bands attempted to relax. The smaller the patch, the more concentrated the energy, producing temperatures far beyond what ordinary matter can contain. Objects placed on or within a decoupled band experienced reduced gravity because the local curvature no longer fully aligned with the surrounding universe. This created an anti-gravity effect. The object was partially insulated from normal gravitational slopes, effectively flattening the local spacetime beneath it. The technology implied by this model revolves around isolating, twisting, or retensioning small patches of spacetime. By cutting the edges of a band, one decouples it from overlying mass and tension, greatly reducing the energy needed to manipulate it. The local torsion then generates concentrated heat that can, in principle, be harnessed as an energy source. Even a microscopic bubble contains immense energy. Its internal torsion and curvature produce extreme radiation and thermal energy regardless of size. This energy is sourced from the geometry of spacetime itself, rather than conventional mass, making it orders of magnitude hotter than any terrestrial or stellar system. Ordinary methods of containment, like water or shielding, are ineffective. The heat and radiation are generated by the band's torsion and relative inertia, which cannot be slowed by conventional means. Any energy applied externally is likely insignificant compared to the self-sustaining internal dynamics. Magnetic or field-based control might influence the bubble, but only if it can couple directly to the space-time geometry. The bubble's own internal laws could prevent ordinary fields or currents from interacting effectively, leaving it largely insulated from human technology. If the bubble is small enough, it can slip along or through surrounding bands without being dragged along by the larger fabric. Its relative inertia and torsion may be far stronger than any energy applied from the outside, meaning it largely obeys its own internal dynamics rather than external constraints. Placing such a bubble on the outskirts of space, far from planets, stars, or dense matter, allows it to exist without catastrophic effects. In low-density regions, the surrounding vacuum can absorb minor leaks or residual forces without danger, making the outskirts the safest environment for high-energy decoupled patches. Its own internal vacuum traps most particles and radiation. The curvature of the bands bends paths inward, keeping energy confined within the bubble. Light, radiation, and particles are largely retained, and only a tiny fraction escapes, limiting the bubble's direct interaction with our universe. From inside the bubble, the external universe would appear invisible or distorted. Conversely, from outside, the bubble would appear opaque or warped. Its decoupled geometry isolates it optically and energetically, creating a self-contained microcosmos with emergent properties distinct from the surrounding spacetime. Even very small bubbles produce far too much heat and radiation to exist safely near Earth. The energy density is orders of magnitude greater than any conventional source, and conventional containment or cooling methods would fail instantly due to the self-sustaining torsion and curvature. The bubble's extreme energy is maintained by its internal torsion, curvature, and relative inertia. Conventional interventions, heat sinks, magnetic fields, or cooling would struggle to significantly influence it. Its geometry-driven dynamics make it essentially invulnerable to direct control unless the intervention acts on space-time itself. Any disruption caused by creating the bubble, such as tearing or stretching bands, would naturally resolve through curvature and reconnection. Because space-time originated as a drifting 1D line, the bands inherently continue their path, bending, looping, and reattaching to maintain continuity. This self-organization allows high-energy patches to exist without collapsing the larger fabric. Overall, the model presents a universe where gravity, energy, and structure emerge from the interactions of flexible, layered spacetime bands. Decoupled patches can produce anti-gravity effects, act as high-energy reservoirs, or even form self-contained mini-universes. The underlying 1D origin of the universe ensures continuity, curvature, and self-organization, allowing extreme local phenomena to exist safely on the cosmic outskirts, while remaining largely inaccessible to conventional intervention. If you want, I can also